Good morning everyone, welcome to the session for computer awareness. This is the last session for computer awareness for the IBPS PO mains examination 2018, and today in this particular session we are going to study about DBMS and operating system. The goals of the class will be to understand the basics of DBMS, that is database management system, and basics of operating system. Again, these are two concepts that are in part of advanced computer science, not a part of the school syllabus. In case you have not done your BSc, BSc, MCA, BTech, if computer science has not been a subject in your graduation, most likely you have not been very familiar with these two concepts, DBMS and operating system, right? So the chances of them appearing in the examination is a little low, but then what we have seen from the paper from the computer aptitude, reasoning and computer aptitude part of 2017 is that some questions from DBMS do occur frequently in the examination, such as questions based on entity relationship diagram, ER diagrams, do come in the examination. So that makes it little tricky to understand what can or what cannot come in the examination. This is why we have covered for you the entire syllabus of computer science for the IBPS PO examination, clear, including computer networks too. So let's start with the basics of DBMS. DBMS stands for what? So what is DBMS? You say DBMS stands for your database. One second. The database management system. Database management system. Try to understand it, because in a computer what we have is information. When you are working on a website, there is a lot of information stored. When you want to go and apply for something online, the data that you provide goes into a table and it's stored there. So database is an integral part of the internet. Database is an important part of application softwares, right? And most of the softwares used in companies for the different requirements, right? For example, when you go to a shop like a big bazaar or some kind of a supermarket and you purchase items, the list of all items and the price, the item code, everything is stored in a database. When you swipe the item for the scan code, right, the barcode of the item, it will match with the table and find out what is the price and everything else, that is stored in the database. If there is a discount on that item, that also is stored in the database. So database plays a very important role. So you can say, what is DBMS? DBMS is a system which connects you, the user, right? You interact with the database management system. So you send some information. Let's say this is the DBMS, right? You send some information to the DBMS, the database management system, through the SQL, that is a structured query language. You want to find out, you send some information, right? And you basically access the application software. It will be that way to understand. The application software then interacts with the database management system. The database management system interacts with the data. So data is stored in a particular location. So the database management system interacts with the data. It stores information in the database, clear, or it modifies information in the database, it removes information from the database, it searches for information in the database based on the SQL command, then gives back it. The data then goes back to DBMS, and the DBMS then interacts back with you, that is the user. So it's the DBMS is an interface then between the user, the application software, and the data that is there in the system, clear? So that's a basic understanding of what it can do. And database, let's go to the key points only. I'm not going to go into in-depth discussion of DBMS and functions and characteristics and all this theoretical part. So let from the exam point of view, what is important, I'm just going to cover that for you, okay? So what we have to understand is database table. So data is stored in a table, as you can see here. In this table we have columns and we have rows. Now, what are rows also called? rows are also called as tuple? That could be one question. And columns are also called, as you can say, row is also called a tuple, and column is an attribute. So you can see column, whether we call it a column or we say an attribute, all are same. Now you see we have here 1, 2, 3, 4 and 5 columns. Each of these is an attribute for a particular table, right? Let's say the name of the table is student. So what do? We give a name to the table and we call it, the table name is there, right? So what is the name of the table? Student. In the student ID is there. This is the student ID which uniquely identifies every student here. So that is the student ID. Then we have the student name, what is the age of the student, what is the class in which he is studying, and which section is he studying in. Clear? Now this is a record. Each of these row is also a record. So understand, a row can be called a record, a row can also be called a tuple. So if you want to fetch the record of the student with having ID 1101, then the record will give you the name as Alex, the age of the student is 14, the class is studying in standard 9th, and which section is studying in A. So what is the table also called? A relation. So this is a basic understanding about these things. What is a row called? A row is called a tuple, row can be called a record, column is there, columns are called as attributes. Each of these attributes, each of this column can be called as is a possible key that can be used in the table. Okay, so for example, I can search in the table for all those records where the students are studying in standard 9. If I do that as an SQL search, SQL is a structured query language, then I should get the name of Alex, Maria and Bob, because all of these are in student 9. But I cannot uniquely search for a record using the key as the class of the student, or the key as a section of the student, or the key as the age of the student, because there are multiple students, multiple rows with the same attribute value. Clear? We can't even use the name, because there can be two students in the class with the same name. So what is uniquely identifying? The student ID. This is our primary key. Now I will be discussing the keys later on. So a primary key is that attribute which can uniquely identify a record in the table. Clear? So no two records will have the same primary key. Now this attribute, the student ID, which is where is our primary key attribute, and all other attributes are called as non-prime attributes. Non-prime attributes can be 0, but prime attribute cannot be null. So when we define a prime attribute, we declare it as not null in the SQL, structured query language. A little bit about database table, and then we go and see what are different types of keys. Just now I have explained to you a primary key, but let's first start with super key. So a set of all possible keys in the system is called a super key, set of attributes within a table that uniquely identifies each record within a table. Super key is a superset of candidate key. So we'll next see candidate key. So if there are number of attributes which can uniquely identify records in a table, all of these can be put in a set. Any of these can be a candidate key, and this set of all candidate keys are called a super key. Now what is a candidate key? A key that can be a candidate of being a primary key is called a candidate key. So candidate keys are defined as a set of fields from which the primary key can be selected. Can you understand this? They are called candidate keys because they are candidates of being the primary key. सुपर की क्या है? सारे कैंडिडेट कीज का कलेक्शन है. द सेट ऑफ ऑल कैंडिडेट कीज, ऑल keys which you think can be used as a candidate key, and then candidate key is the set of all keys which you think can be used as a primary key, right? It is an attribute or set of attributes. It is an attribute or set of attributes that can act as a primary key for a table to uniquely identify each record in that table. तो दो चीज़ें देख ली हमने. कैंडिडेट की जो है वो सुपर की के जो सेट से चूज की जाती है, राइट? और कैंडिडेट कीज में से हम चूज करते हैं प्राइमरी की. लेट्स लुक एट प्राइमरी की. प्राइमरी की इज द कैंडिडेट की दैट इज मोस्ट अप्रोप्रिएट टू बिकम मेन की ऑफ द टेबल. जैसे कि स्टूडेंट नेम भी एक प्राइमरी की हो सकता था, बिकॉज बट देन देयर इज द पॉसिबिलिटी दैट देयर आर मोर देन वन स्टूडेंट विद द सेम नेम, सो वी डोंट यूज student name as a primary key, we use student ID as a primary key here, correct? So suppose student name is there, Suppose we have a phone number. If we add a phone number attribute here, let's say this is a phone number. Now phone number can also uniquely identify a student, but there are possibility that two students who are come from the same family, the two siblings are there who are from the same family, and both of them have registered the same phone number with the school authority. In that case, the same phone number will give you two records. That is why the best would be the student ID. So we go to the table, we see, okay, which of these can be the best possible primary keys, and we put them all together, say these are the candidate keys, and from the candidate key the most appropriate one can be then chosen as the primary key of the table. Clear? Next is a key that consists of two or more attributes. Sometimes one attribute is not sufficient, right? So we say that two or more attributes are required, then that key is called a composite key. Now for example, in best to understand is customer ID and order ID. When you go to purchase something online, right, there is an order ID for that product, clear, and the order ID must be matched with the customer ID for that product to be delivered to you. The order ID can uniquely identify the order, but then how do we link the order with who has ordered it? For that we need the customer ID. So customer ID plus order ID combined can become a composite key that can then uniquely identify a purchase made on the website. Clear? That is what is called a composite key. तो काफ़ी सिंपल तरीके से समझ रहे हम लोग ये. These are very simple concepts. This primary key, super key, candidate key, composite key, so that it's not difficult for you to understand even if you are not from computer science background. Let's see the candidate key which are not selected from primary key are known as secondary keys. तो हमने सभी keys select किए थे कि these are the possible candidates of being primary key. All of those keys were called candidate keys. From the candidate key, we selected one key and we said that this will be our primary key. So the other keys which were not selected, they will be then called as the secondary keys. That means if required, we can use them as alternate keys or secondary keys. What is a foreign key? A foreign key is a field in one table that uniquely identifies a row of another table. Clear? That is what is the concept of a foreign key. For example, customer ID can then go to the next table in which the purchase is there, and it can act as a primary key there. So a foreign key is a field in one table, an attribute in one table that uniquely identifies, which works as a primary key of another table. You understand? An attribute of one table which works as a primary key of another table is called a foreign key. So suppose we have one table here, and in this we have a customer number and order number, an invoice number, and another record is there in which the company maintains all the invoices and how much money has come, and in this we have invoice number, and this invoice number is acting as a primary key of this table. So this is table 1 and this is table 2. So the key in one table is acting as a primary key of another table, then this will be called a foreign key. What is it? A foreign key. I think that's a very easy to understand concept. Now what are non-key attributes? In the beginning itself I told you those attributes, those columns which are not primary key are called as non-key attributes. Other than candidate key attributes in table, non-key attributes are other than candidate key attributes in table, and non-prime attributes are attributes other than primary attributes. That means in all the records, all the attributes which are not prime key, the primary key, are called as non-prime attributes, and all the attributes that are not candidate keys are called as non-key attributes. Alright, so we have understood now what are keys. Next let's look at anomalies. Right, so in database, when you make a table, one of the jobs of the database manager, the one who is managing the database, is to remove anomalies from the data. Right? Anomalies means errors. We have to remove the errors from the data. So let's look at this particular table and understand there are three types of anomalies. One is updation anomaly, one is insertion anomaly, and one is deletion anomaly. This is very easy to understand. Let's look at updation anomaly. Now you see here, there are two records. One is student ID 401 and student ID 404, both of them are for the same person Adam, who stays in Noida. You see, when he enrolled for the subject for bio, he got a student ID 401, and when he enrolled for physics, he got a student ID 404. So there are two of these which have the same address. So if I want to update now, if I want to update the address of Adam, then I have to update the address of Adam in all places in the table. This is not very correct, because if we update only in one place, that will be problematic. So this kind of a situation where we have to change addresses or entries in multiple records is what is called as an updation anomaly. A good database should not have this problem where the person has more than one records having the same address, right. So if updation anomaly means that if we change a particular field in a record, then the same field has to be changed in multiple records. This should not be the case. Then insertion anomaly. Suppose we insert a new student. If we insert a new student here, let's call him student number 405, and let's call him Raj, and let's say he stays in some place, let's say called Gurgaon, and he has not taken any subject. So if you insert this field becomes empty, and this is again not correct for a good database, and this problem is called as insertion anomaly. Clear? So when a problem happens, when you insert a data and some fields, some records are empty, some attributes are empty, then it creates what is an insertion anomaly and deletion anomaly. Suppose I delete one student, let's say for example I delete this student who is studying let's say, now for example I delete Jammu. So now if I delete 403 Stuart Jammu, now we will have no information for this particular place Jammu, because that was only for the student Stuart. So when we remove a particular record in a table, and because of this we lose one of the property, one of the attribute values, then that is what is called a deletion anomaly. Next we will look at what is normalization. Normalization means when we have a database, it has to be normalized, it has to be improved. So normalization is a way of improving the database. Clear? So what is the purpose of normalization of data? Two main things are there. One is to remove the anomalies. Clear? Remove the anomalies. Second is to remove the dependencies. Now how do we remove anomalies and dependencies? To what level we have removed anomalies and dependencies? Sometimes removing all dependencies and removing all anomalies can be counterproductive and create so many tables in a database, and instead of benefiting it causes you harm. To what extent do we aim to remove the anomalies and dependencies decides the level of normalization, and we start with the first level of normalization, that is called as first normal form. The first normal form is a very simple one. The first normal form says that every domain should contain atomic values. Clear? That means that no attribute must have two words, you can say. That means the values cannot be divided. For example, Ram Kumar is not an atomic value, but Ram is an atomic value. This is called as atomicity. So what happens? Suppose we had a table like student ID, name, right, and then we had phone number, and we had something like course, and in this we had student ID 1 and the name of the person was Ram Kumar. Clear? And the phone number was, let's say, 1234, and the course was A. Now in this case, this particular attribute is not atomic. This is not atomic because there are two words here, Ram and Kumar. Suppose we take the name of all the persons in the same way. Tomorrow you have information that one person called Ram was there, and but I don't know the surname of that person. Clear? So but I want information about this particular person. I want to find out who this person is. Now you want to search in the table for this person Ram, but it is not possible because you have taken the name in the field as Ram Kumar. The SQL query will not be able to search for Ram separately. So what you do is you improve this table. You say let there be 5 rows instead of 4 rows. So you will say let there be student ID, let's call something as first name, and last name. So let's segregate them. Okay, first name, last name, phone number, and course. So now we have made 5 5 records, 5 attributes. Sorry, 5 attributes. So now the ID is 1, and then we have Ram in the name of the first name and Kumar in the place of the last name, and then we have phone number 1, 2, 3, 4, and the course is 1A. This is what is called as 1NF. The benefit is that if I want to search for all the persons who have the first name Ram, I can do that now. Clear? Next, let's look at second normal form. So what does second normal form do? First normal form, very simple. It removes all non-atomic values and makes everything into atomic values. Atomic values means only one word can be there in a particular attribute. Now, if something is already in the 1NF, that means first normal form, and we want to improve it further to the second normal form, we have to remove partial dependencies. If there are partial dependencies, there will be problems that will happen in the data in the future, right? Different types of anomalies will start happening if we have partial dependencies. Now let's just look at this table on the screen and understand very easily what is partial dependency. Now you see here, roll number 1, person playing cricket, name is Amit and the fees is 200 and grade is A, 2 is badminton and 4 is badminton. Clear? And so now you see here, the name of the person is dependent on roll number. So I can say that roll number defines the name of the person. Clear? So name of the person is completely dependent on the roll number. But you see, there is one problem here. The fees for cricket is 200. The fees for cricket is 200. Wherever we have cricket, no, the fees is 200. And wherever we have badminton, the fees is 150. That means that the game is the one which is defining the fee. So fee is dependent on game, whereas name is dependent on roll number, and roll number is our primary key. That means we have an attribute here which is dependent on another attribute which is not a primary key. This should not happen, because this is what is called as partial dependency. What we should know as a rule is that every non-prime attribute should be fully dependent only on the prime attribute. So this is the aim of second normal form. Let's quickly understand the third normal form. If something is in second normal form and all transient dependencies are removed, then it is said to be in third normal form. What is transient dependency? You see, if B is dependent on A and C is dependent on B, then C should be dependent on C. Now this is what is called as transient dependency. If we remove transient dependencies from a database, then it will become in third normal form. The other normal forms also, like Boy Scout normal form, then project joint normal form, that is not in the scope of your preparation. Normally I don't expect you to get a question on normalization, but still I have covered this for you for your benefit. What is more important for you from database management system is ER diagram. Entity relationship diagram is more important for you for your exam purpose for IBPS PO mains. So what is ER diagram? First of all, this is entity relationship diagram, and the relationship between different entities, that is what the purpose of this. It helps the database creator in creating the data. How am I supposed to create data? How many tables do I need? What will be the primary key in each table? What will be the foreign key in each table? How will they relate with each other? That we have to understand before we make the tables, right? We can't make the tables and then start looking at the relationship. First we have to find out the relationships. We have to understand the relationship between the different things and then decide how to make tables. So a simple rectangular box represents an entity. What is an entity? An entity is a table. What is an entity? Entity is a table. A table is a relationship. Each table is represented by a square rectangular box. So we have student table, we have the subject table, right? A student table will have student ID and student roll number, the student phone number, the student address and all those things, and subject ID will be there. Subject ID, subject name, subject fees, that will be the subject table. Student is studying a subject. That's the relationship between which two things? The entity student and the entity table. The student is studying studies. Okay, so this is the relationship, and what he studies? A subject. Clear? It will be a many to many relationship, many to many, because many students can study many subjects. Okay, it's not, and many subjects can be studied by one student or many students. So that's a student studies a subject. So this is what is a simple rectangular box in the ER diagram represents a what, a table, an entity. And the purpose of an ER diagram is to show the relationship. What do we show? Relationship. And you see relationships are represented by diamonds or rhombus shape. Relationship between two entities. Now a relationship, just now I have shown you, relationships can be shown by rhombus shape. We can have a strong relationship, we can have a weak relationship. Okay, just like we can have a strong entity and a weak entity. So a strong entity is one which we show by a rectangle, and this is a strong entity. And if we have a rectangle with bold lines or a rectangle with two lines, double lines, then that is a way of showing that this is a weak entity. What is a weak entity? A weak entity is one which stand alone does not make any sense. It must be linked with some other entity, then only it makes sense. That is why we call it a weak entity. For example, order ID is a weak entity and customer ID is a strong entity. So we see here a weak entity is one which is dependent on a strong entity, which cannot alone stand in a table. Clear? And when we connect a strong entity with a weak entity relationship, then we use this diagram. When we connect a strong entity with a strong entity, when we use this diagram, that's what we have to understand about rhombuses. Next is an ER diagram is ellipse. What is an ellipse? This is an ellipse, right? This is an ellipse. Ellipse is used to represent attributes. What do they represent? Attributes. Like book can have two attributes, author and date of publishing. Clear? These attributes are represented by oval or ellipse shape in the ER diagram. Okay, next is this already I have shown to you, weak entity and strong entity and weak entity. All right, let's understand a number of things here. What is a key attribute? When we say key attribute, we say primary key attribute. So how do we show the primary key attribute? By underlining. So if you underline an attribute, it means this is my primary key. This is my primary key. This is a table. Name of the table is person, and person has got a number of attributes. So what is a derived attribute? A derived attribute is shown by this dotted line. This is a derived attribute. That means it is system derived. When you put the birth date, the system can automatically find what is your age right now. Clear? So it's a derived attribute, system generated attribute. You don't have to type it. Now there are some multi-valued attributes like hobbies. There can be multiple hobbies for a person. So we use two concentric ellipses for showing multiple multi-valued attributes. And what are composite attributes? Like name is a composite attribute because it's got two other attributes to it, first name and last name. So all these are the what we say as attributes. Clear? Different types of key attribute, derived attribute, multi-valued attribute, composite attribute. Let's now move to types of relationship: one to many, one to one, many to one, many to many. For example, there's one college. There's a college in college name, college address, in which many students are there, and one to one where two things can be related only one to one. Many students can take the same subject. Clear? One subject can be taken by many students, that's many to one, and we can also have many to many relationship. This is not that important. ER diagram is very important for your examination. Alright, now let's understand operating systems. So DBMS, whatever is required for your exam particularly I have covered for you. Let's focus on operating system. So what is an operating system? It's a system software. Also there are application softwares also in it, So there's a system software which we have other system softwares like drivers, which helps you interface with the hardware. You see, application software. The human users can interact with application software. The application software then interacts with the operating system. If required, it goes through other system software, and finally the interaction with the hardware, or directly we can interact with the hardware. So understand, operating system is a software that allows the human users to interact with the hardware of the computer. It's an interface between the hardware and the users. An operating system is an interface between the hardware and the user. Like popular operating systems, Windows, Linux, all of these operating systems are an interface between the hardware and user. That's one basic understanding of operating system. Important functions are there, so all of us can understand what an operating system can do. Just now I told you it is basically an interface between user and hardware. It helps you in managing the memories. For example, you have the primary memory, that is the RAM. So it helps you in managing memories, what should go into the RAM, and from the RAM it's used by the processor. So managing of primary memory is done entirely by the operating system. It also manages processor. So how should the processor work, how should we schedule different jobs for the processor, because in a computer there are so many things running together. Suppose I have Microsoft Word, Windows open, and then there's an MP3 player also there, and there's one website also I'm browsing side by side, and I'm trying to use all of them together, right? So there's so many interrupts that I'm giving to the CPU, to the operating system. The operating system will decide which job to do first, who will schedule the job. The job scheduling part will be that of processor management, how to allocate the processor for doing different jobs. Device management, which devices have been installed and how to use a device, all those things. File management, so files are there in the hard disk, which again the operating system will manage. Security, to make sure that there is a firewall in your computer and your computer is protected from security threats. Monitor system performance, so it keeps a tab of CPU temperature, the fan speed, and overall how the processors are using the CPU and optimizing the CPU. That monitoring such job system performance, job scheduling, error detection, and log also is done by the operating system. Questions of operating system has not come so much till now in your examination, but again when they can ask questions from DBMS, why can't they ask questions from operating system? So we are covering these, some of the common things, simple things for you, so that every concept is covered for your examination. Now different types of operating system. The earlier systems in 60s and 70s, we had the batch processing operating system. So number of users would create their own programs in batches into punch cards, and then they would be punched one after the other in the operating system, and the operating system will then execute these jobs. It was a very slow system because the speed of the computation done by the operating system and the speed of the hardware was not matching. Then came the time sharing operating system, that is Windows or Linux. All of these are examples of time sharing operating system, in which suppose there are n jobs, then each job is given a time stamp, and then in a round robin scheduling or first in first out scheduling, we give them time to access the CPU. This way multitasking can happen. Then we have distributed operating system. Suppose there are 5-6 computers all connected together, and a computer is there which is showing you as one computer, but actually 5-6 computers together, and it improves the capacity of computation done by a computer. This kind of a system is called a distributed operating system. A network operating system is where the operating system is on a network computer server, which is then connected to all other workstations, the printers, scanners, and it's being controlled from the central server. That is called a networked operating system. And embedded operating system is one which is embedded on small devices like PDAs and PLC, programmable logic controllers and personal digital assistants. So in the small devices we have an operating system that is embedded. Now users cannot do much change in the operating system, and the operating system directly does all the work. This is called an embedded operating system. It's very light in terms of the size of the operating system, and it's got limited functionalities, but it is very robust, light in size, and fast. Real-time operating system is used in things like robotics and artificial intelligence, in which the operation and the interaction happens in real time. So these are some of the names that you should be familiar with in terms of types of operating system. Common operating systems: Windows started with 95, then 98, then Windows 2000, Millennium, XP, we had Windows Vista, Windows 7, 8, Windows 10. So basic versions of Windows, the basic familiarity with Windows you should have. Macintosh operating system, Mac OS, is used in the Apple computers, right? And then we have the Unix system developed by the AT&T and Bell Labs, which is a very different operating system compared to Windows, because Unix uses what is called a monolithic kernel, whereas Windows uses a micro kernel, in which the micro kernel has a small size and monolithic kernels have a large size. Basically, in simple terms, I'll explain to you that in Windows we install the operating system, and then it's our choice what applications we want to install. They want to install Microsoft Office or not, or want to install other application softwares in Windows or not. Whereas in Unix or Linux, everything comes together in one kernel, everything is there. You don't have to install drivers, you don't have to install application softwares, browsers separately. Everything is already existent there. So that way the size becomes very large, whereas Windows the kernel size is very small. But the problem is that in Windows, because we are uploading the application software additionally, it is slower than compared to Unix or Linux. Now Linux is basically a Unix based operating system created by Linus Torvalds. That's called Linux. Linus Torvalds and Unix together becomes Linux. It's a Unix based operating system. It's an open source operating system. That means it is free of cost. Anyone can use this operating system and create another operating system if they want. A number of operating systems today are all based on Linux, like Ubuntu, is Solaris. All of these are operating systems based on Linux. Symbian, Android and iOS are mobile based operating systems. Symbian is used by Nokia, right? Android is used by all Android phones, and iOS is used by the iPhone. The Apple phones which you have, they all use the iOS operating system. The basic names of some of the operating systems you should be knowing. That's all. It's not that in-depth questions can come about semaphores and processes and process control blocks and instruction queues and deadlock detection, avoidance. All this is like really advanced concept of operating system that we cannot expect in a PO examination. Basic questions like what is the operating system, or different types of operating systems, some of the functions of operating systems that can come in your examination. So from the point of view of your PO mains exam, I have covered every topic that can come from computer science in 7 sessions of computer awareness, right? So I hope you had followed my classes, and that must have helped you prepare for your PO examination. So now the time for the class practice pack. Those who have passport access will start solving the questions as they hear the sound. The question which you get wrong, I will discuss in my later classes. And best of luck to you for your examination, PO mains examination, and thank you for watching the video.